STE. Electronic telepayment system. The STE is an original electronic payment system, patented in Spain. Video 2 of 2. Introduction to this second part. In the first video, it was exposed, the STE interface, the form of identification of the buyer-payer, the form of payment and the essential characteristics of the payment. It was also said that the security of this payment system was based on a symbiosis of method and system and that this was possible thanks to the STE interface. Well, the STE, in addition to the advantages that it has as a payment system, that is to say, in relation to the way in which payment is made between the buyer and the seller, it also has other advantages such as a payment system in a general sense. And, to expose what these other advantages are, we will talk here about encryption method, security in the payment institution, security for the buyer-payer, and expedited payment. Encryption method. The STE interface, due to the way it is conceived, allows multiple encryption possibilities, and any encryption method will be valid if it meets the two basic requirements of STE. It is worth remembering here, what are these two basic requirements established by the STE, and that were exposed in the first video. 1. Encryption customization. That each payer has its own and exclusive encryption. 2. Individualization of the payment. That each payment uses a different encryption, so that once an encryption is used, it is not used again. Now, taking into account the peculiarities of the interface of the STE, that one method or another of encryption be adopted, may result in increased security measures in general. In this video, to see in a more graphic way other security possibilities of the STE, we will use a cipher system that I call key texts. Later it will be understood why this encryption method was chosen. This encryption method, which I call texts key, consists of that the text to be encrypted, i.e., the payment order. It is combined with other text, one or several times, resulting in an unreadable text, the encrypted text. This is a well-known and simple method, which in principle does not require further explanation, although here, we will briefly explain its development, with a practical case as an example, since this will later facilitate the understanding of the security options that the STE generally provides, as an electronic payment system. Practical case by way of example. Previous questions. Before exposing the practical case, it is necessary to record some previous issues, so that what is said here can be understood. The first. A. In this payment system, what is encrypted is the payment order. Payment order that contains all the necessary data to be able to make the payment, amount to be paid, purchase details, bank account where the payment is made, PIN number, etc. B. Here, to make the exposition shorter, we will encrypt as a payment order what could be the object of the purchase, for example, book, Roman Empire. C. Remember that the encryption parameters are on the USB memory, see video 1. The second. The encryption method, in this example, will be performed following the following parameters. A. The characters of the text to be encrypted and each one of the characters of the key texts are replaced by a value. B. value of characters. See Table 1. However, the values could be other. For example, the a value of 236, the b a value of 157, etc. c. The payment order to be encrypted is combined 3 times with the key texts and in the following way: 2 additions and 1 subtraction. Third, the key texts. The so-called key texts is actually an illegible text, unreadable text that may be set a in a paragraph, see box 1, b in multiple paragraphs with the same character length, for example, 10 characters each paragraph, see box 2, c in multiple paragraphs with a variable character length, for example, between 5 and 15 characters, see box 3. Note: this assumption, C, will be the one taken as a reference for this practical case. And the cipher program will use as many characters, or group of characters, as are necessary to reach the cipher. Practical case 1. Text to encrypt. The payment order. In this example, and in order to make the explanation more brief, we substitute the content of the payment order for what could be the object of the purchase: book, Roman Empire. See Table 2. 2. The cipher program. To perform this specific encryption, the first thing it will do is count the number of characters of the text to be encrypted. See Table 3. Text to encrypt. Roman Empire book. Number of characters 21. The second will take from the key texts the triple number of characters that make up the text to be encrypted. In this specific case it will take 63 characters. And taking into account that in this example, the key texts are made up of groups of paragraphs with a different number of characters, the cipher program will gradually take groups of paragraphs until it reaches 63 characters. In this specific case, to reach 63 characters, it will take paragraphs 1 to 8. See box 4. Taking into account that paragraphs 1 to 8 add up to a total of 67 characters. The last 4 characters are not taken into account and are eliminated, so that the key text to use would be the one seen in box 5. That divided into 3 parts of 21 characters would be, see Table 4. The third encrypts the payment order, and for this it combines the payment order 3 times with the key texts, as follows: 2 sums and a subtraction. See Table 5. In order to combine these characters, what the cipher program does is replace the characters with their value, as seen in Table 6. Once the encryption program replaces characters with its value, you can now operate with these values, and it will do it in the following way. First column. To the value 12, it adds value 3. The value 19 is added, and the value 6 is subtracted. The total result is 28. If we do the same operation in all the columns, the result is what you see in this table. This being the encrypted text. To decipher the payment order, what you have to do is reverse the process, and they will give us the following values. See Table 8. If we substitute the values for the corresponding character, we will obtain the legible payment order. See Table 9. It was said that this encryption system was very simple, but that it was used as an example, because it would allow other security possibilities of the STE to be seen graphically. Well, to see these other security possibilities, it is convenient to remember the following: the table with the value of the characters, see Table 1, and the key texts, see Box 3. Security for the payment institution. Although this is not usually said, cybercriminals sometimes obtain the data to impersonate the buyer, payer, from the payment institution itself, without the payment institution being aware of it. Well then, the STE interface allows adopting measures that minimize the possibility of cybercriminals obtaining from the payment institution the necessary data to impersonate the payer. This will be verified graphically with an example. The buyer-payer 1 says that you want to buy a product and pay with the STE reference 0. The seller 4 sends the buyer-payer the data to make the payment, reference 01, and also remit to your collection entity 3 the sale data, reference 02. The buyer-payer, with the data received, complete the payment order, and remit to your payment institution 2 the payment order, reference 5. This payment order contains in this example 3 sections: the legible name of the buyer-payer, the encrypted text, what is actually the payment order, a reference, in this specific case, 8 to 21. Note: reference 8 is the last key text used, and is filed in the buyer-payer's cipher program, in a specific folder. This reference varies with each payment. Reference 21 is the number of characters in the payment order. This data varies with each payment. The payment institution 2, upon receiving the payment order 5, the first thing it does is see who sends the payment order, and verifies that the buyer-payer has its payment system operational. The second thing it does is request the key texts departments 2B, 2C and 2D, the paragraphs of key texts up to number 8. Departments 2B, 2C and 2D send you all the paragraphs up to number 8. See Box 4. Note: Department 2A knows that the last key text used is 8, because the payer so indicates in the payment order, but 2A doesn't know if this is correct. Paragraphs are stored in departments 2B, 2C, and 2D randomly, and each department does not know in which of the other 2 departments are the other texts. The third thing is to ask Department 2E for the encryption parameters. See Table 1. The fourth, you already have all the necessary elements to decipher the payment order. Decrypt the payment order. If you decrypt the pay order correctly, what you need to do is verify that the PIN number matches. In fifth place, ask the department for PIN codes 2F, the PIN code of the buyer-payer, and verify that it matches the PIN of the payment order. In sixth place, verified that everything is correct, it informs the payment department 2G to make the payment, and the payment department 2G makes the payment to the collection entity 3. Conclusions regarding the security that the STE gives to the payment institution. First conclusion. In this diagram, we can graphically verify that in this example, the payment data of the buyer-payer is located in 5 departments: 2B, 2C, 2D, 2E and 2F. This means that, for a cybercriminal to obtain all the parameters of a buyer-payer from the payment institution, they need to enter 5 departments. This provides the payment institution security guarantees superior to other payment systems, even against some unfair worker, because no person has all the payment information. Second conclusion: if the key texts used are for single use, and once used they are deleted, this means that with each payment made by the buyer-payer, it modifies the encryption references with which the payment references at a given time are no longer valid at a later time. This forces criminals to update the encryption data at all times, which makes criminal activity very difficult, and it makes it easier for the payment institution to detect intruders. Keep in mind that they have to enter 3 departments at the same time. Security for the buyer-payer. The STE automatically detects fraudulent payments. With a certain frequency, the buyer-payer does not find out that they are making purchases at his expense, until a certain time has passed. This is due to the fact that, among the multiple payments that one makes, some payment to majors is easy to go unnoticed. Well, with the STE, the buyer-payer would automatically discover the fraudulent payment in the next payment that he made, after the fraud. With a simple example it will be perfectly understood, and for this, we will continue with the previously exposed practical assumption. The buyer-payer, 1, says that you want to buy a product and pay with the STE reference 0. The seller, 4, sends the buyer-payer the data to make the payment, reference 01, and also sends to your collection entity 3 the sale data, reference 02. The buyer-payer, with the data received, reference 01, complete the payment order. Note: to encrypt the payment order, the cipher program uses the key text paragraphs from 9 to 31. The encryption program uses paragraphs 9 to 31, because paragraphs 1 to 8 were already used in the first purchase. Once the encryption is complete, the encryption program leaves a record in the last text key used folder, reference 31. Payment order completed. Issues the payment order 5 to your payment institution 2. This payment order contains in this example 3 sections: the legible name of the buyer-payer, the encrypted text, what is actually the payment order, a reference, in this specific case, 31 to 55. The payment institution 2, upon receiving the payment order 5, the first thing it does is see who sends the payment order, and verifies that the buyer-payer has its payment system operational. The second thing it does is request the key texts departments 2b, 2c and 2d, the paragraphs of key texts up to number 31. Departments 2b, 2c, 2d should send all key text paragraphs up to number 31. And taking into account that in the previous purchase made by the buyer-payer, the last key text used was 8. The key texts that should be sent in this case are from 9 to 31. However, as stated at the beginning of this section, in the hypothetical case that someone had managed to make a fraudulent payment, the buyer-payer would automatically realize when making a purchase after the fraud. Well, to verify that this is so, suppose a criminal managed to make a fraudulent purchase. This implies that the offender, to encrypt the payment order, you have had to use key texts, which are for a single use, which means that the key texts used by the delinquent, they are automatically eliminated in the key text departments of the payment entity, departments 2B, 2C, and 2D. And continuing with the practical assumption, here two assumptions can occur. 1. That the offender had used a number of key texts greater than 31. In which case, departments 2B, 2C, and 2D will not send any key text. 2. That the offender had used a number of key texts less than 31. For example, up to key text 25. In which case, the key text departments will send the key texts from 26 to 31. Both in one case and in the other. Department 2A cannot decipher the payment order. At that moment, payment entity 2. You already know that an incident has occurred in the payment system of that payer, and you can now take action. Payment entity 2 notifies the buyer-payer of what has happened and that his payment order will not be executed until the incident is resolved. With this simple example, it has been possible to verify how, when the buyer-payer makes a purchase after the fraud, both your payment institution, as the buyer-payer itself, they are automatically aware of this incident, which allows to block the payment system until the reason for the incident is determined, thus avoiding possible fraud. Not having to give an identification key provides extra security. As has been said, with the STE, the buyer-payer does not have to provide any identification key, which prevented criminals from obtaining any data to supplant it. Well, this also provides extra security to the buyer-payer, regardless of the payment system. Indeed, very often criminals contact the payer, posing as their payment institution, and inform them that someone has tried to make a fraudulent payment, and that you should change the payment password at that time. If the buyer-payer changes the password at that time, this allows criminals to clone the payment keys at that moment. However, this type of fraud cannot be carried out with the STE. Since the buyer-payer does not use any identification code, it is identified with its legible name and surname. Fake websites, pirates. Sometimes, the buyer-payer enters a false web page, thinking that it is the original one. And it is normal that you do not realize the deception, because they are identical to the originals. In this case, basically two assumptions can occur. 1. A real purchase, but your identification data is hacked. 2. A fictitious purchase, with which they defraud the amount of the purchase. Well, with the STE, this does not happen. 1. Real purchase, but the identification data is hacked. The buyer, 1. Enters a pirate website thinking it is the original. This website, what it does, it is inserted between the buyer-payer 1 and the seller's website 4, so that the buyer-payer makes the purchase, not directly, but through the pirate website. And at the time that the buyer-payer 1 gives his identification data to make the payment, the cybercriminal clones your identification data. The buyer-payer receives the product, and he does not imagine that his identification data has been cloned. By having payment details cloned, cybercriminals can make purchases without the cardholder's knowledge. 2. Fictitious purchase, with which they cheat and steal the amount of the purchase. The buyer makes what he believes to be a purchase and consequently authorizes the collection of the amount. The amount is withdrawn from your account, but never receives the object of the purchase. STE and fake web pages. With the STE, the false web pages lose effectiveness, because who has to give the data for the payment is the seller. With a simple example, in 2 parts, it will be much better understood. First part. Buyer-payer decides to buy a shirt, enter the seller's website, in this case Zara. He buys the shirt and says he pays with the STE. Consequently, Zara communicates his data to the buyer, so that he can make the payment. In this case, the account holder is Zara. Second part. The buyer-payer decides to buy a shirt and unknowingly enters a pirate web page that says, Zara, but it is not the official Zara page. He buys the shirt and says he pays with the STE. Consequently, the delinquent must communicate his data to the buyer, so that he can make the payment. And in this case, he can no longer appear as the owner of the Zara account, but the cybercriminal must appear as the account holder. That is to say, in the STE, the cybercriminal has to give the true data of his income account, and logically, the comparator payer, seeing that the account holder is not Zara, will not make the payment. Nor would it be effective if the offender deceives us with the data he gives us. For example, the offender superimposes the correct data from Zara about his own data, the cybercriminal's bank details. So, in the data that one reads, it appears as the owner of the Zara account, but the real owner is the cybercriminal. Why wouldn't it be effective? Because the buyer-payer does not authorize any collection with the data it receives. The bank details you receive are automatically integrated into the corresponding boxes. And the payment order is encrypted with the data that appears in said boxes. These are boxes that do not admit more references than those that appear in them. But further, the collection entity, in order to collect, must have previously received a notice from the seller with the reference of the sale, with which it is also identified. We must remember here that the STE operates on a digital payment collection platform, where the payment entity and the collection entity function as a single entity. Expediting payments. With a certain frequency, there is an agglomeration of payments at specific moments, so that paying by card involves a considerable delay. A typical case is at the beginning of the vacation. When one stops to refuel at a gas station, fills up the tank, and when he goes to pay, he finds that there are 10 other people in front of him. If everything goes well, when you finish paying, about 15 or 20 minutes have passed. In addition, during all this time, the car is parked at the pump, preventing other cars from being able to fill up. Well, the STE allows in these specific cases, expedite payments. With a practical example, everything will be understood much better. Suppose 10 gas pumps, which are currently being used by 10 other vehicles, fill the tanks. And they have to pay. Well, with the STE, it is not necessary for each driver to go to the central cashier to pay and wait one behind the other to pay. It is enough that each dispenser has a monitor terminal that automatically provides Bluetooth, NFC, screen capture, or in any other way, all the data to the driver for payment. Payment data that can appear on all monitors virtually at the same time. Each driver verifies that the payment details are correct. And each one executes the payment order through their mobile phone, which means that the payment order can be executed by all the drivers at the same time. It can be said that each driver's mobile becomes a POS, point of sale terminal. At the moment the gas station receives the payment confirmation. Appears on the monitor screen, paid. And it turns green, for example. The driver also receives confirmation of payment. And you can continue your journey. Thank you very much for your attention. And, hoping that the information given has been of interest to you, J.F. Manso says goodbye to you.